the let me show you an application of the implicit differentiation. So the following is called the logarithmic differentiation. So suppose you have y equals to x plus 1 squared times x plus 3 cubed over square root of x times cube root of x plus 2. Okay? Suppose you're given this, and the question is, find y part. Imagine yourself taking the exam and the question was this one. That would be very hard, right? You would really hate the professor after seeing this, right? Because not only you have to use the quotient rule, this is product rule, and all the numbers are so messy. However, there's a very effective method in dealing with such a thing. The idea is to take the log of both sides. So we're going to take ln of both sides. And by the way, let's rewrite the radicals into powers. Square root is same as 1/2 power. X plus 2 is same as 1/3 power. Okay. So I took the log of both sides. And when you have logs, logs are very effective at writing and simplifying exponents. So one thing that you can do is, if you have a division, you can make it as a subtraction. Log of division of two things becomes subtraction of two logs. Okay, so division inside a single log becomes subtraction of two logs. And then multiplication inside a single log becomes addition between two logs. You remember that formula, right? Okay, and since this is together, when you put it into two logs, you should put a parenthesis, or else you're going to end up with the wrong sign. Okay. So the rules that I'm using so far is that ln of a over b is ln of a minus b, ln of a minus ln of b. ln of a times b is ln of a plus ln of b. I like to imagine myself as an axeman trying to chop up wood. With a single piece of log, chop it off, and the multiplication breaks up into two logs. That's how you make things into images, and it's easier to remember that way. And it's especially important to remember that you have two logs after you split them. A lot of people forget to put the second log, and you get totally wrong. Now I'm going to use another formula that you probably learned, but you may have forgotten. I think I talked about this. Jump the frog. So if you have some exponent inside the log, that number can jump in front of the log like a frog, right? So C ln of A. So these are, in addition to this, you have the base change rule, which we are not going to use, so it's not too important here. But we will be using this one here. So 2 jumps over the log, like a frog. 3 also jumps in front. 1/2 jumps in front. 1/3 jumps in front, but with this minus sign, it's negative 1/3. ln of x plus 2. Okay. So this is what you would get if you took this original equation and tried to split as much as possible. Okay. And remember, because this thing came from here, which is same as log of y, this end result is still same as log of y. So we have this following equation, and to this we may apply the implicit differentiation, right? We can just differentiate both sides. Now let's think about what you would get if you differentiate log of y. Log of y prime. Remember, y is a function of x, right? So if you differentiate this, you have to use the quotient rule. First, you differentiate this function as a function of y, which is 1 over y, but then y, which is the nested function inside the log, has to be pulled outside and differentiated, okay? So inside function gets pulled outside and you have to differentiate. So you end up with y prime over y. So that's what you would get if you differentiate the left side. Now, let's think about what you would get if you differentiate each individual terms. Okay? So if I differentiate the left side, I get y prime over y. Whereas on this side, it's all chain rule, except this one. That's very easy. If you differentiate this as 1 over x plus 1, then you have to pull the inside function outside and differentiate. But what's the derivative of the inside function? No, x plus 1 differentiates to? 1. So it's times 1. I'm not going to write that times 1. Same thing here. All these inside functions differentiate to 1, so we don't have to multiply anything. It's just this, and then this one differentiates to 3 times 1 over x plus 3 minus 1/2 times 1 over x minus 1/3 times, if you differentiate this using the chain rule, log x differentiates to 1 over x, so if you differentiate log of x plus 2, it differentiates to 1 over x plus 2, and when you pull this out and differentiate the inside function, you get 1, so you don't get. So this is what you get, and therefore, what is y prime? Y prime is finally this multiplied to the right side is the answer, right? So you can write down this times the other one. So, but instead of writing down y, you can just, since you already have y solved explicitly, why not use this? So we can write down the derivative as the original function, which was a very crazy looking function. Times this thing inside, and it's very long, but you just have to write them all. I mean, it's not easy, but it's still better than trying to solve the original derivatives using a bunch of quotient rule and chain rule and product rule. This is a lot more convenient if you compare the two. So So that's the answer, that's the derivative.